Good morning, I'm Timothy Priscilla and I'm doing some Simplex method used on a standard maximum problem for my Math 1324 class. And notice in this problem we're about to work, I have 4 decision variables, x1, x2, x3, x4. So that graphical method really could not be applied here. That graphical method can be used on those problems with 2 decision variables, x and y, so you can draw the graphs. Here, we'll set up our matrix. We have 4 x's, so we'll have an x1 and x2 and x3 and x4. How many slack variables will we have? Do you remember how many slack variables we'll have? That depends upon the number of less than or equal to inequalities. So there are 2 of them, so we're going to have 2 slack variables. We need a column for z as well. So we're going to have 3 rows in this matrix. The coefficients for x1 are 1, 3. Remember what we do with the slack variables. We pick them up, the objective function. We pick them up, move them over to the left side, so that 1x1 becomes a negative 1. So we have a 1, 3, negative 1. We have a 2, 1. Change the sign, negative 2. We have a 1, 3. What number goes here? What number will we have here in our x sub 3 column? We have a 1, 2, no. We have a 1, 2. We have a 1, 2. I'm glad I'm using pencil here. And move that over. It's going to become a negative 1. What numbers are going to go in the x sub 4 column? Which numbers will go there? It'll be a 1, 1, and negative 5. How do we fill in these 3 columns we added on, the slack variables and the z column? Remember, those special columns there always fill in 1, 0, 0, 0, 1, 0, 0, 0, 1. I'll draw a vertical bar for my column of constants. We have a 50, a 100. What goes here? All of those terms in the objective function were moved over to the left. That's how their signs changed. So what do we have remaining on the right-hand side? Nothing. That first number down there is always going to be a 0. As long as we have negative indicators, then this number is not the maximum value of the function. We certainly have negative indicators. If there are negative numbers on the last row, then you haven't found the maximum value yet. So, how do we get started? You select the most negative indicator. So that would be negative 5. You choose that means the negative number with the largest absolute value. So you want the most negative here. That determines our pivot column. Then we determine our pivot row. To determine the pivot row, you take the number in the column of constants, divide it by the number in the pivot column. 50 divided by 1 is 50. So let's see. I better write it here. We have 50 divided by 1, which is 50. And we have 100 divided by 1, which is 100. Which one of those do we use? For the quotient, you choose the smallest positive quotient. Smallest positive. The smallest positive is 50, so that's going to be our pivot row. You choose the most negative number on the last row. That determines your pivot column. Then you divide the numbers in the pivot column the column of constants by the number corresponding value in the pivot column. 50 divided by 1, 100 divided by 1. You use the smallest positive quotient, which in this case is 50. So our pivot row is going to be row 1. We go to the pivot, the number that's common to both the pivot row and pivot column. We need that number to be a 1, and fortunately for us, it's already a 1. It's already a 1, so that's saving us from having to divide to turn that number into a 1. We use this 1 to zero out the column. Using this 1, we would go, what does this 1 need to be? So when you add it to positive 1, it gives you a 0. Well, it needs to be a negative 1. So negative 1 times row 1 plus row 2 gives me a new row 2. And what does that pivot need to be? So when I add it to negative 5, I get a 0. That would be a 5 times row 1 plus row 3 gives me a new row 3. So row 1 is not changing. Row 1 is going to stay 1, 2, 1, 1, 1, 0, 0, 50. I'm recopying row 1. Rows 2 and 3 are going to change. Multiply by negative 1 and add it, that gives me a 2. Multiply by negative 1 and add it, that gives me a negative 1. Multiply by negative 1 and add it. Multiply by negative 1 and add it. Doing the same thing all the way across. Multiply by negative 1 and add it. Multiply by negative 1, that gives me a negative 50. Add it to 100, that becomes a positive 50. Now we're ready to work with row 3. Oh, this process. What do they call this process? When we have the 1 in our pivot entry and we're zeroing out the column. What do they call that? They call that pivoting. That's what we're doing now. We're pivoting to get those zeros. So multiply by 5 and add it. That'll be a 5 plus a negative 1. That's a 4. That'll become a 10 minus 2, which is an 8. 5 minus 1, another 4. This is looking real good so far. Why am I saying that? I'm saying that because remember, if you have negative numbers remaining on the last row, then you're not finished. You're going to have to repeat the process. So maybe we'll have time to do one of those in another video. Multiply by 5 and add it. Multiply by 5 and add it. Multiply by 5 and add it. 5 and add it. Multiply by 5, that gives me a 250. Add it to 0 to give me a 250. There are no negative numbers remaining on the last row. Once again, you can have negative numbers appearing in the matrix. You just can't have them in the last row. There are no negative numbers remaining in the last row, so we know that we found the maximum value. Remember how the columns were labeled? Let's see. I'm writing no blanks here, and we'll fill these all in. I'm grouping all the original variables. There, I'm grouping all the original variables together. I'm going to separate the slight variables just because the slight variables are the ones that weren't in the original problem, okay? So, looking at the matrix, which ones do we set to 0? Remember I said you could tell them. The ones you set to 0 were the ones that have numbers other than just a single 1, all the rest 0. That has all those other numbers, so x1 is going to be set to 0. All those numbers there, x2 is going to be set to 0. All those numbers, x3 is going to be set to 0. What else is going to be set to 0? x4 isn't. x4 has the 1 and all the rest 0. Is s2 going to be set to 0? No, because it has a 1, all the rest 0. S1 is the one that gets set to 0. So now I'm able to read out the remaining values, once I cross out all the ones, are set to 0. For x sub 4, you move down to wherever the 1 is, move across, x sub 4 is 50. For s sub 2, I move down to wherever the 1 is, I move across, s sub 2 is 50. For z, I move down to wherever the 1 is, I move across. So the maximum value of z is 250. It occurs when x1 is 0, x2 is 0, x3 is 0, and x sub 4 is 50. So, and this is what you should do. It should be your goal to be able to do it like this, where you don't write out the equations, you go from the statement of the problem directly to the matrix. You perform you find your pivot and do your pivoting until you have no negative indicators, and then you go from that final matrix directly to the answer. So hopefully you see the pattern I'm using here. Okay, I'm going to look and see if I can find another problem to do in a little bit. But for now, bye-bye.